Hello, thanks for joining my session. It's a pleasure to be here presenting at DevSecCon 24. I will be talking about the risk of CI/CD pipeline poisoning via CodeBuild and basically security around the CI/CD pipelines a bit in general. In enterprises, we attempt to make it secure, we harden it, we configure it in a way that is hermetic, so we build trust. Our goal is actually to automate and make sure that every time we give an input, we have a trusted application at the end of this process. However, I will demonstrate that with a very simple action, it's actually possible to break this trust and introduce some new risks into your CI/CD pipelines if you have them in AWS. Before getting into the topic, I would like to speak a bit about myself. My name is Asier Rivera Fernandez, and I work at PwC Belgium. I work at the Department of Cyber and Privacy, but I'm originally Spanish from the North region, the Basque Country. I started studying IT in my bachelor in Spain, and then I moved all the way to the other side of Sweden, of Europe into Sweden, where I did my master's thesis, and I tried to come slowly backwards towards Spain, and I ended up in Belgium doing my master's thesis, where I now work and live. I do enjoy brainstorming and all these crazy sessions in which people put crazy ideas on the table. Most of the times they are useless, but for those that actually work out, I think it's really worth it. And I like football. I played through all my life, I guess, as a Spanish person, it's kind of mandatory. I enjoy board games, and I also like cooking, but I'm not that good at it. Okay, so let's get into the topic. Why did I look into security for CI/CD pipelines in the cloud? Well, it covers two of my passions. The first one is secure development, application security, and the second one is, of course, cloud security. And like most of the people in the world, I got into cloud. I started to learn about the services, how they actually work together, what are the possibilities, basically the building blocks. But when I started looking into more specific cases for enterprises that may require really specific CI/CD pipelines, things start to become a bit more complex in the sense that the cloud service has been designed to be used in a specific way, although it covers a wide range of use cases. It may be that it doesn't fit together. And out of this, I started thinking, is it possible that some of these configurations that we adapt to our needs may break or affect the security posture of these CI/CD pipelines? So I decided to start by looking into AWS for no really particular reason. The goal is actually to move on and evaluate the other cloud providers as well. And I took the area that I like, which is DevSecOps. And I looked into the CI/CD pipeline related services. I did some risk analysis after a deep dive, some threat modeling. And the goal is for me to really understand what key aspects I need to take into account when setting up secure CI/CDs. So as I said, I looked into the common AWS Managed Services for CI/CD pipelines, CodePipeline for the pipeline execution and management, code commit for the Git repositories and code management. Then for the building part, there is CodeBuild, which via containers, it allows to execute this task for configuring and compiling the code into a valid application. This computing power can also be used for unit test or any other kind of testing that you need, but you can also easily hook third-party solutions. And last, there is the CodeDeploy for the automation of the deployment part. Quite simple. I also looked into other concepts. So source package, once more, very simple, is basically taking the Git repository that is stored in code commit, packaging it in a zip file, and is used by CodeBuild as an input in order to actually do the compilation and the configuration of the final application. In this case, includes source code, configuration files, typical Git repository resources. Then we have the artifact package, which is basically the output of this CodeBuild, and it contains the application bundle already ready for deployment. It also includes configuration files for the server and scripts that you maybe need to run in order to configure, install, and adapt the environment to the new version. And this artifact package is used by CodeDeploy in order to install this application at the end of the pipeline. And we're going to focus on server deployment, although artifact packages and CodeDeploy support also serverless via a container or Lambda functions. And last, another two concepts, the build spec file. Very simple file. It just contains the environment variables, parameters, and commands to be used and executed within the CodeBuild container. Basically, step by step, what the container needs to do to take the source code, prepare it, compile it, and get a final application. And second, the app spec file, which is really similar, once more, a file with scripts and commands to be executed. This one is run at the server and is done via the CodeDeploy agent, which is an agent service that is installed on the services that CodeDeploy will call to request to do a new deployment. As I mentioned before, there are different deployments supported. So Lambda and container are not really shown here because we are focusing on the server deployment. And I also looked into what kind of interactions and actions we can actually do with these services, which type of functionalities they provide, not just the common ones, automated ones by AWS, but everything you can actually do with these services. And I came across this very simple action, the StarBuild action. It belongs to CodeBuild, and basically, as the description states, it starts running a new build. Makes a lot of sense because somehow we need to tell CodeBuild how to start the job. And I also looked into who actually should have access to these actions, in which it is a quite hard task because you cannot really go to enterprises and ask them, please provide me your policies, your access policies, because that's quite private. So I had to find something to use as baseline, and I used the AWS Managed Policies, which they are created and managed by AWS security engineers and identity and access management engineers, and they are created with two support basic roles. For example, the administrator, developer, or read-only for CodeBuild. So both of them, the administrator and the developer, have the access to the StarBuild actions, so they both can start a build. It makes a lot of sense. The admin may need to troubleshoot something. The developer may need here or there to test a small thing. So why not start a new build? However, the policy states clearly that the developer doesn't have access rights to administer the pipeline or the CodeBuild project. So no default configurations can be changed. This means that you can be sure that your administrator will harden and configure the pipeline in a way that is secure. You can build your trust on that one, and the developer is only going to be able to use it without modifying things. However, this is not completely true, because I found that you can abuse the StarBuild functionality to perform three abuse cases. The first one, you could exfiltrate sensitive data. This is security related resources like passwords, configuration files, etc., sign-in certificates, you name it, or even intellectual property, because the application that you are building could actually be sold to customers, right? Second, you can tamper with the application. The same way that the building process is going to happen, you can spice it a bit and add some malware or malicious functionality like backdoors, that then it could be deployed in the server or distributed to customers. So it doesn't sound that good. And third, I will demonstrate that you can run privileged commands in the deployment server. This is done if you are using the full AWS CICD services, including CodePipeline, CodeBuild, and CodeDeploy as the key points of your pipeline. Of course, to achieve this, the developer doesn't just start running a build, and there are a couple of functionalities extra that the documentation includes, but may not be that clear at first sight. The first functionality is via the artifacts override parameter, and it allows the developer to start a build and modify for this build only the output of the artifact package. So what comes out of CodeBuild normally is stored in an S3 bucket, but for this build only, you can actually define a new one. The fact that it mentions for this build only, it kind of gives the sense that it's not really powerful. And also, it does not really break what the developer policy mentioned. You cannot really change the default configuration only for this build. So why wouldn't you give it? And then the second parameter, even more powerful, is the build spec override, which allows developer to define a new build spec file. So I already mentioned this determines which commands are executed in the container. So basically, for this one only, you can define what the container will execute. So how can you leverage this to exfiltrate sensitive data? The first option, you can just ask CodeBuild to run a normal compilation execution, so normal build task, and state, please store it in my own S3 bucket instead of on the one that is on the enterprise account and is actually hardened where you don't have access to. At the end, you get a valid application bundle that you could put in the black market or make it publicly available. And if your enterprise is making profit out of selling that application, well, Yeah, it's a bit gone, this version. Good luck with new features. There is a new option, a second option, sorry, which is using the build spec override parameter. In this case, since you can define which commands run in the container, you can ask, please do some SCP or some post request, take those resources out into my own server, and it's a very similar approach, gaining access to sensitive data, signing certificates, whatever that the container has access to. As part of the building process, it can be exfiltrated. To do this, of course, you need to get access to the internet, but by default, the containers used by CodeBuild actually leverage this access, so it should be doable. Second, tamper with application, similar approach. A developer can define with which commands are going to be executed in the server, in the container. So these commands can actually modify the artifact package that is the outcome of the build process, including some malware, for example, modifying the actual source code to inject new functionalities. You name it, this artifact package can be then selected for delivery, to install in servers, or to be sold to customers. And third, run privileged commands in deployment server. Once more, similar approach. Build a spec file override to determine what the container runs. This container has access to the artifact package. And this artifact package, if you're using the full AWS code services, it will contain this app spec file. This app spec file, as mentioned before, will contain the commands to execute on the server. So once this artifact package is selected for deployment, your commands will execute. I'm aware that I mentioned is privileged commands, and you don't really need a 0-day or any kind of privilege escalation technique. You can use app spec file features like the run as property, and then the CodeDeploy agent will run the commands as root for you. There is a small problem here is, in order for this to actually work, we need that our artifact package is actually selected for deployment. This is done if your package is the latest version, for example, but it doesn't work like this with CodePipeline. Because CodePipeline randomizes the name of every package for every execution. So source package, artifact package, any other package that you are building throughout your pipeline will have a randomized name. This helps CodePipeline to keep the versioning, but you cannot guess the number. So we need to find out which is the name of this randomized artifact. So I looked into it also, and there are two options. Of course, CodePipeline knows which randomized name it generated and needs to keep track of it. And the second option, CodeBuild needs to know it because at some point during the execution, it was able to store the legitimate artifact in an S3 bucket. So the first option needs one action, CodePipeline list action executions. And this one is not included as part of the CodeBuild policy. So it can be that your developers don't have it. However, it's quite a low risk action, and it will allow the developers to keep track and monitor the pipeline execution. So to see all the green lights step by step. So it's quite likely that they have it. However, it's not really a problem because the other one, the CodeBuild option, you need two actions, but both are included as part of the developer policy that I showed before, the AWS Managed one. So if you are using that one, your developers will have all three actions required. So how does it actually work? Well, I will showcase the steps, and I will use the CodePipeline Poisoning Tester, which is a tool that I have developed composed of an API for monitoring purposes and a script that is actually the one doing the actions with the goal of automating the steps that a developer could do to abuse the StarBuild action. It's available on GitHub, so feel free to go and have a look. And how does it work? Basically, it is in the build phase where the script is actually going to do most of the job, which is at this phase, CodePipeline has generated this randomized name. So at that point, our script, the tool, is going to request that name. Once it's found, it will ask CodeBuild to start a new poisoned build. This is going to happen kind of parallel to the legitimate build. So the legitimate build will always finish before. The legitimate build package, artifact package will be stored in the S3 bucket, and then we will start a poisoned build. In this case, we use the override parameters. So the artifact override will specify the randomized name of the legitimate package. So when it is stored, it overrides the good one. And the second, we leverage the build spec override to inject our own malicious poison on the script. But the tool doesn't do any harm to your system, so it's okay. It does two tasks. The first one is it sends a post request to the CPPT API. For monitoring purposes, Also to demonstrate that the container or the server where these are executed have access to the internet and demonstrate that data filtration is possible. And the second task is to create a file. This happens at container side, and in this case, the file is stored at the artifact package to demonstrate that you can tamper with the artifact package to include other things. And it also happens at the server where a file is created at the root directory with root access rights, of course, to demonstrate the risk of code execution. And I have a live environment demonstration for this. So I have a nice video. In the left-hand side, you will see the enterprise point of view, the AWS environment. There you go, the Hello World pipeline. In this case, you have the source and the build phases with code commit, code build, and then there is others which covers the manual approval. So all those unit tests, etc., you can put them there, and the deploy via CodeDeploy. Of course, the enterprise also has a deployment server, which I will show in a second. There we go. It's just a basic Amazon Linux 2 AMI. There's nothing really installed. I want just to show that the root directory is clean. It doesn't contain any strange files. So I will list it. Can take a second. There you go. There is no cppt was here file, which is the one that our tool will request to be generated when poisoning. And now I will show you the part of the developer. So the cppt tool, the script will be in the right-hand side and the API will be shown in the left-hand side. There you go. So in the left, you see the API, which contains the URL and the key. That is provided to the script in the right-hand side. So we will target the Hello World pipeline and we will provide URL and API key. And there is also the credentials of the user in between that I will show in a moment. There you go, the IRF dev. This one has only one inline policy with 2 actions. There is no other type of boundaries. And it provides the code pipeline options. So list action executions and StarBuild. There are no groups or no extra actions allowed. And this is the access key, the only one that is provided to the script so that the script can call the services on behalf of the developer. So now let's see it in action. I start the script, which you see it is not allowed to do code build. Of course, it doesn't have those access. So it went for the code pipeline option, and I start an execution of the pipeline. In this case, the source works quite fast, but we're not really interested into the source package. We are interested into the artifact package name. So the build goes on in the next phase. And here the legitimate one is running. At some point, code pipeline is going to notify CodeBuild the name of the randomized new artifact package, and our tool is going to be able to find it. There you go. At that point, it does the 2 steps. The first one is to start a new Poison build. So our Poison build is already ongoing, and it reached out to the API to notify I poisoned a new execution, and it will now monitor it. So you can see the table. There will be a moment in which the container will reach out to the API. It may take a few seconds. Normally, it's under 30 seconds, but there it is. And now I just go and continue with the execution as normal. Manual approval, everybody, all the stakeholders were okay with the results, so why not? Let's go on, and we go to the deploy phase. Here, similar, the server needs to download the package. It will open our Poison one and take the app spec file, and it will reach out to the CPPT API. This may take a few seconds. There we go. So it already notified. Most likely our file is already stored. And the deploy phase still needs to finish. So for the sake of all the green lights, let's wait for it. There it is. I go back to the server. And I will do exactly the same process. I will just list the root directory to show you that the file is actually there. Let's wait a few seconds. There it is, created as root. So that's basically it from the live demo. Now, when I realized about these potential risks, I put them under the view of experts in the team, and we try to be critical and evaluate whether these risks are actually relevant for the real code. Because is exfiltration really an issue, since our developers can already read the code and read the documentation, so they have a lot of information, and this is true. But putting aside the security-related passwords, configuration, signing certificates, in many enterprises, in confidential projects, the code base is divided into different layers. These can be components, libraries, or even branches, and the access is actually segregated. So in this case, this allows bypassing those cases because CodeBuild requires access to the full source code, and not only a part that the developer may have access to. Second, tampering, is it really a problem? I mean, our developers can write the code that gets into the pipeline. And it's true, and this is a known risk, and that is why in a secure SDLC environment, security controls are implemented like peer code review to avoid that one person only can actually just push code that ends up in the application to avoid these rogue developers. However, CodeBuild allows to bypass those and inject code directly during the building process, so there is no real way to check it. Third, is execution really a problem, especially in modern and very agile CI/CD pipelines? Developers become really important, and they often have access throughout the full pipeline, including the server instance to do some configuration tasks or other installation tasks that are required. And this is true, but in that case, this is a risk that is known, accepted, and potentially security controls are implemented to limit the access of that developer. However, with this risk, CodeBuild allows you to find a shadowy way to get into the server, and potentially you will never find out what actually went wrong unless you're aware of this potential risk. And last, these developers are actually our colleagues. We have coffee with them, we have lunch with them, so we should trust them, right? And that's true, but I would like you to consider some other cases like credentials can be leaked. It couldn't be the first time that GitHub, a repository that is publicly available, contains developer credentials, and there are others like blackmailing or other types of breaches, right? So we took all this and we notified AWS because we thought this is an issue. This should not really be allowed, or at least it should be more obvious that this action is more than just start running a build. And we thought somehow that the problem was on the software level. So the design of this functionality was not properly thought from a security mindset, because it allows quite a lot of powerful actions. But AWS responded that this is intended behavior. StarBuild functions as they expect. There is nothing but, and this is true. And they also state that it's the responsibility of the customer to define who actually has access to this action and whatnot. We can discuss whether it is properly explained, how critical it is, and whether they use it or not in their policies in a more easy or more confidential level manner. But yeah, it's the way it is, it's their decision. So it's basically our problem to take care of it. That's why I would like to propose a couple of approaches that you can reduce or mitigate this risk. The first one is, if you can deny the access to the StarBuild action, just do it. Let's go and put an explicit deny. And then automate the execution, the start of the pipeline execution. This can be done via hook. So every time new code is pushed to the master branch, start a new pipeline execution. Why not? I know that this does not fit everybody, because some specific needs will require your developers to somehow start in a more manual fashion these builds. And if that is the case, I see two options. The first one is your users don't require these override parameters. And in that case, you can use a Lambda function as a proxy. So the developer will call the Lambda function, and the Lambda function will call the StarBuild on behalf of the developer without using the override parameters. The second option, and the most complex one, is if you really need those override parameters for your developers. In this case, the best option is to rethink your CI/CD pipeline. So identify and evaluate those sensitive tasks like code signing, for example, and then split them. Make sure that they are in different CodeBuild projects and that they are ordered. The ordering is important, because if you allow human access to tasks prior to, for example, that code signing, everything that happened before has effect. So if new code is introduced, it is signed, and then it becomes trusted. And last, deny access, especially to the sensitive tasks, and as many tasks as you can, of course. So that is everything from my side. It has been a great pleasure to be here with you today. I hope you enjoyed it as much as I did, and I hope to see you soon. I will be answering your questions in the chat, so feel free to comment and share your questions, of course.